Hi students, now we are going to do the fourth experiment, that is band gap energy of a semiconductor diode. So before going to start the experiment, we want to know what is a semiconductor. Generally, the materials are classified into three categories. One is conductor, semiconductor and an insulator. So conductor அப்படிங்கிறது என்ன? The material which is said to be a good conductor of electricity is called as a conductor. That is, all the metals are said to be conductors. Then what is an insulator? A material which does not conduct electricity is called as an insulator. For example, glass, wood, plastic, all these things are said to be insulated. Between the conductor and the insulator lies the thing called as a semiconductor. As the name itself indicates, it is a semiconductor, which we call it as a partially conducting material. So semiconducting materials are nothing but called as partially conducting material. They neither behave as a good conductor, they not behave as a bad conductor. So that is what called as a semiconductor. Example, germanium, silicon are said to be a semiconductor. Right. Then now we want to know what is a band gap energy. In case of semiconductor, there are two bands. One is called as valence band, which is called as the lower energy level, and other one is called as the conduction band. So usually all the electrons will be present only in the valence band, and almost the conduction band will be empty when the temperature is equal to 0 Kelvin. So for example, we can say that at low temperature, at 0 Kelvin, all the electrons will be present only in the valence band and the conduction band will be empty. For conductivity to take place, the electrons should move from valence band towards the conduction band. So for example, I am giving some energy. It may be a heat energy or it may be a light energy. So we are going to use some sort of energy. That energy will be absorbed by the electrons in the valence band and they move towards the conduction band. Now the electron will be in the conduction band and holes will be created in the valence band. Once the electron starts to move from valence band towards the conduction band, now the conductivity, which is indicated by sigma, will start to increases. So now the semiconductor will start to behave as a conductor. Now the gap between the conduction band and the valence band is called as the band gap. So what is a band gap? That is a gap between the valence band and the conduction band is called as the band gap. So how much amount of energy has to be given to a material for the electrons in the valence band to go towards the conduction band? That is called as band gap energy. It is called as the band gap energy. So in our experiment, you will be given a semiconducting material. It may be a germanium or it may be a silicon. So you have to find what is the band gap energy of a given semiconducting diode. So that is what is your experiment. So what is the formula used? So the band gap energy is calculated by using the formula 0.188 into slope. So from the graph we are going to find the slope value, where slope is equal to delta log is by delta 1000 by t. Here is